In previous sessions, we have talked about the alkane and alkenes, two groups of the hydrocarbons. In this session, we want to talk about the alkyne. Same as the previous ones, we will draw their structural formula, both condensed and uncondensed format. Then we will look at their molecular formula and their name. The first member of the alkyne homologous series must have two carbons, because you know that in the alkyne we have triple bond between the carbon, at least one triple bond between the carbons. So the first members must contain two carbons, which there is a triple bond between them. Now we have to put the hydrogen for each of these carbons. The carbon which is written at the left, three of its valence electrons are shared with the carbon at the right. So only one hydrogen is needed. And the carbon at the right has the same situation. Three of its valence electron is shared with the carbon, so it only needs one hydrogen. This is uncondensed structural formula for the first member of the alkyne homologous series. Its condensed structural formula is CH, triple bond CH. Its molecular formula is C2H2. You have two carbon and two hydrogen in the molecule. And the name of these member comes from the name of the alkane. The alkane with two carbons is ethane, but here we have ethine, Y-N-E. Okay, so A-N-E in the alkane converts to Y-N-E. The next member must contain the three carbon. So I put the triple bond for the first two carbons, then I put a single bond for the next one. The carbon which is at the left, it only needs one hydrogen, but the carbon which is at the middle, all of its four valence electrons are shared. Three with the carbon at the left, one of them with the carbon at the right. So it doesn't need any hydrogen. The carbon which is at the right side needs three hydrogen. This is uncondensed structural formula for the second member of the alkyne homologous series. Its condensed structure, the first carbon has one hydrogen, then it has triple bond with the carbon, but this second carbon doesn't have any hydrogen. It has single bond with the carbon which has three hydrogens, CH3. The formula for this compound is C3H. Okay, so you can count the hydrogen here. There are four hydrogens, so it's C3H4. And the name of the alkane with three carbon is propane. So here it becomes propyne, Y-N-E at the end, propyne. The next member has four carbon, so C triple bond C, single bond carbon, single bond carbon. Now I have to add the hydrogens. The first carbon needs one hydrogen. The second carbon doesn't need any hydrogen. The third one needs two hydrogen. And the last one needs three hydrogens. The condensed structural formula is CH, triple bond C, single bond CH2, single bond CH3. And its molecular formula is C4H. Again, you can count the hydrogen in this molecule. There are 6 hydrogens, so it's C4H6. And the name of that would be butane. So the hydrocarbon with 4 carbon member starts with but. Because this is alkyne, it becomes butane. So you can guess what is the name of the next alkyne, because from 5 carbon upward, the name comes from the Greek number. The 5 in the Greek becomes penta, so this one becomes pentane. Pentine. Let's draw the structure of the pentine. So you have 5 carbons. There is a triple bond between one of them. 4, 5. We have to add the hydrogens. The first carbon needs 1 hydrogen. The second carbon doesn't need any hydrogen. The third one needs 2 hydrogen. The fourth one also needs 2 hydrogen. And the last one needs 3 hydrogen. The condensed structure formula would be CH, triple bond, C, CH2, CH2, CH3. So in this manner, we can draw the structure for the rest of the alkyne, but it's not necessary because you know how are they. So the next member, which has 6 carbon, would be hexane, and its condensed structure formula would be CH, triple bond, CH, CH2, 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 CH3.
So shouldn't it be CH triple bond C?
Yeah, this one should be C. Sorry, I made a mistake. Okay, because it has 4 bonds. Okay, so you can see when we are adding 1 carbon, the only difference between them is a CH2. So compare the propyne with butane, it has 1 extra CH2. Then compare pentane to butane, it has 1 more CH2. Compare hexane to pentane, it has 1 extra CH2. Let's write the molecular formula for pentane and hexane. For the pentane, it is C5H8. For the hexane, is C6H10. So you can see for each one of them, the difference is CH2, 1 carbon, 2 hydrogens. So this shows that they are belong to same group of the organic molecule, which we call them, they are alkyne homologous series. But same as the alkene, the position of the triple bond is also important. So I can draw another hexane here. Instead of triple bond be in the first position or between carbon number 1 and number 2, the triple bond can be between the carbon number 2 and 3. So I can have single bond between first carbon and the second carbon, then I can have triple bond. Okay. So I'm drawing the hexane, so I need 6 carbons, 1, 2, 3, 4, 5, 6. Let's put the hydrogen. The first carbon needs 3 hydrogens. The second carbon doesn't need any hydrogen because all of its 4 valence electrons are shared. The third one also doesn't need any hydrogen, but the next carbon needs 2 hydrogen. The next one also needs 2 hydrogen, and the last carbon needs 3 hydrogens again. The condensed structure formula would be CH3, single bond carbon, triple bond carbon, single bond CH2, CH2, and CH3. This is the straight chain alkyne with the 6 carbons. So this one is also hexane. So we have to distinguish between these two. Both of them has the same molecular formula, C6H10, but they are different molecules, so they are isomers of each other. Same as the alkene, to distinguish between the alkyne, we have to number the parent chain from the side which triple bond receive a smaller number. Obviously, for the first hexane, we have to number it from the left side because the triple bond is written at the left. So this is carbon number 4, 5, and 6. The position of the triple bond is important. It's between carbon number 1 and carbon number 2. So we consider the smaller one. We say the triple bond is in the first position. So in the name, we have to write 1 hexane. This 1 refers to the position of the triple bond. And as I have mentioned earlier, you can also write hex 1 ein, but your book used the first method. So for the rest of our lesson, I use the method which is used in your textbook. Okay, so I write 1 hexane. What about the Next one, the next one, if you number it from the left side, 1, 2, the triple bond would be on position 2. But if you number from the right side, the position would be 1, 2, 3, 4 on the fourth. So you have to number the hexane from the left side because the triple bond receive a smaller number, and this one is 2 hexane. Also, it's possible that the triple bond between in the third position. So you can have CH3 connected to CH2 connects to carbon with triple bond carbon connects to CH2 connects to CH3. So here also you have 1, 2, 3, 4, 5, 6 carbon with a triple bond. So your molecule is hexane, but the position of the triple bond is on the third carbon, so it's 3 hexane. For this molecule, there is no difference from which side you number it. If you number it from the left side, this is carbon number 1, carbon number 2, carbon number 3, 4, 5, 6, and the position of the triple bond is on carbon number 3. If you number it from the right side, it's carbon number 1, carbon number 2, carbon number 3, 4, 5, 6. Again, the position of the triple bond is on carbon number 3. So for this case, it's not important from which side you number your parent, because from the either side, the triple bond would be on the third position.
Same as alkane and alkene, which there are relationship between the number of the carbon and the hydrogen. For alkyne also there is a relationship between the number of carbon and hydrogen. If you look at each of these molecular formula for the members of the alkene that we have here, you probably can find the relationship between the number of hydrogen and the number of the carbon. For the alkyne, the number of the hydrogen is twice as the number of the carbon minus 2. So if, for example, you have 2 carbons, the number of hydrogen is 2 times 2 minus 2, which becomes C2H2. And if you, for example, has 4 carbons, the number of hydrogen is 2 times 4 minus 2, which becomes C4H6, as you can see here. So if we want to summarize the relationship between the carbon and the hydrogen for 3 groups of the hydrocarbons, for the alkane, the relationship is Cn H2n plus 2. For the alkenes, the relationship is Cn H2n, and for alkyne, the relationship is CnH2n minus 2. So if a molecular formula for a hydrocarbon is given to you, by looking at the relationship between the carbon and hydrogen, you must be able to identify which group of the alkane does that compound belongs to.
If you don't have any question, we move to your textbook to write down the naming of the alkene and alkyne which has branches. So I go to your textbook on page 691. It's systematic names of the alkenes. In previous session, we have explained about the alkenes, but only we have introduced the straight chain alkenes. We have not talked about the alkenes which have branches. So we want to name these alkene which is given here. So when they give you a hydrocarbon and they ask you to name it, the first thing that you have to do is to check what do you have. Do you have alkane, do you have alkene, or do you have alkyne? Here, because we have double bond, it means we have the alkene. Okay, so how we used to name the hydrocarbons, the alkane, we have to find the parent chain, the longest chain, which is called the parent chain. But when you have the alkene and alkyne, it's very important. The longest chain that you choose must contain the double bond. So it means maybe there is a longer chain in the alkene or alkyne, But if it doesn't contain the double bond or triple bond, you are not allowed to choose that one as a parent. So look at the molecule which shown on the right side here. The blue chain which shown here is longer than the red chain which shown on the molecule at the left side. So here you have 1, 2, 3, 4, 5, 6 carbons. But here you have 1, 2, 3, 4, only 5 carbons. But you are not allowed to choose this one because this chain which you have chosen doesn't contain the double bond. So when you want to choose the parent chain in the alkene and alkyne, you have to find the longest chain of the hydrocarbon which contain the double bond or triple bond. So the longest chain is this one which is shown here. What is here is a branch. The name of the branch is ethyl. It has 2 carbons. You have to number your parent because you want to mention the position of the branch. If you remember, for the alkane, we said we number the parent chain from the side which branch receives a smaller number. But for alkene and alkyne, you have to look at the position of the double bond or triple bond. You have to number your parent from the side which the double bond or triple bond, or is better to say generally the functional group receive a smaller number. Okay? This double bond and triple bond is called functional group. So it shows the specific type of the organic molecules. So if you have double bond, you have alkene. So we say the alkene, so the double bond is a functional group of alkene. If you have triple bond, the organic molecule is alkyne. So the triple bond is a functional group of alkyne. In the next session, we will talk about the functional group in more detail. So for here, I have to number the parent from the left side, 1, 2, 3, 4, 5, because from the left side, the double bond would be on the first position. If I number it from the right side, the double bond would be on the fourth position. So no matter if the branch is at the right side of your molecule, you have to number it from the side which the double bond receive a smaller number. So we can say the priority is with the double bond and triple bond, not with the branch. So now the rest of the system is like the alkane. First, you have to mention the name of the branch and location of that. The name of the branch is ethyl. It's on the second position. So you have 2 ethyl, and then you have to mention the name of the alkene with the location of the double bond. The double bond is in the first location, and you have 5 carbon, so it is 1 pentene. So this is the name of the molecule which you have here. Okay, so it's written here 2 ethyl 1 pentene. Sometimes in some molecules you have 2 double bonds, as you can see in this molecule. When you have 2 double bonds, at the end of the name, you must say diene. It means you have 2 double bonds. If you have 3 double bonds, at the end of the name, you must use triene. Tri means 3. You have 3 double bonds. And if you have 4, it becomes tetraene, but it's very rare. We have up to 3 in your book. So look at this molecule which is written here. In molecule, you have 2 double bonds. So it means your molecule is alkene. You have to find the parent chain. Here, you don't have any branch. It's the straight alkene. So you have to number it from the side which the double bond receive a smaller number. Let's number it from the left side. This would be carbon number 1, this carbon number 2, this is carbon number 3, this is carbon number 4, and this is carbon number 5. So where are the location of the double bond? The first one of them is here on carbon number 1, and the second one is here or carbon number 4. So as I said, it's between carbon number 1 and 2, but we consider the smaller number. And the next one is between carbon number 4 and 5, but we choose the 4 for the position of the double bond. Now, if I number it from the right side, This would be carbon number 1, this is carbon number 2, this is carbon number 3, this is carbon number 4, and number 5. So the first double bond appears on the first position, and the second double bond is on the fourth position. So you can see for both of them, the situation is same. So no matter from which side you number it, the location of the double bonds are in the first and fourth position. So in front of the name of the parent, you have to mention the position of these double bonds. The double bonds are on the first and fourth position. Then you have 5 carbon. So the 5 becomes penta, the Greek number. And then because you have 2 double bond, you have to mention diene. So this one becomes 1,4 pentadiene. Or you can also mention you have penta 1,4 diene. Both of them are correct. Here it shows that these 2 double bonds are on the first and fourth position. Same thing here. When you say 1,4 pentadiene, it means these 2 double bonds that you have here are on the first and fourth position.
Sir, I have a question. If there's an alkyne which has 2 triple bonds, will it be like, for example, pentadiene?
Diene, exactly. We will have that example.
Okay.
Yeah, it would be like that. Okay, so here the detail for the naming is explained, but I have explained it to you. So let's go and name these alkene. So the first step, I have to choose the longest chain, and the longest chain must contain the double bond. If I go from here, 1, 2, 3, 4, 5, this is the longest chain that I can find here, but I'm not allowed to choose that one because it doesn't contain the double bond. Okay? So this would be wrong. The longest chain which contains the double bond is this one. It has 4 carbon. Okay, and we have 2 branches here. One of them is CH3, which is methyl. The other one is CH2, CH3, which is ethyl. And we have to mention them in front of the name of the parent. But before mentioning them, I number the parent. Here, I have to number the parent from the right side. So the parent chain, this would be carbon number 1, this carbon number 2, this one carbon number 3, this one is carbon number 4. Because if I number it from the right side, the double bond would be on the first position. It receives a smaller number. Now, I name this molecule. I have to mention the name of the branches first, but we have to look at their alphabetical priority. This is M, this is E, so ethyl has to be mentioned first. Its position is on the second carbon, so I have 2 hyphen ethyl. The methyl is on the third position, so hyphen 3 methyl. You can see between the number and the letter, I put the dash. Now I have mentioned the name of the branches and the position of them. So here I have to write the name of the parent. The parent has 4 carbon and the double bond is in the first position. So I have 1 butene. So the molecule is 2 ethyl, 3 methyl, 1 butene. Let's do some more example, which you have here, the practice question. Let's do the first one. So name the following alkene. So we know that these molecules are alkene. The first one is just a straight chain alkene without having any branches. We have to only mention the position of the double bond. From which side I have to number the chain here?
On the right.
From the right side, yeah, obviously, because from the right side, the branch receive 1, 2, number 2. But if I number it from the left side, it is number 1, 2, 3. The double one appears on the fourth position. So this is wrong because from the right side, it receives a smaller number. So this is carbon number 1, 2, 3, 4, 5, 6. So the alkene with the 6 carbon, it is
Hexane.
Hexene, E-N-E, but the position of the double bond is on the second carbon. So I have to mention 2-hexene. Okay, the next one, I choose the parent first. The parent chain is this one, the longest chain which contains the double bond. It has 4 carbon. I have to number the parent. I have one branch. The branch is methyl. I can number the parent from the left side. It becomes 1, 2, 3, 4. The double bond is on the second position. If I number it from the right side, this is carbon number 1, this is carbon number 2, this is carbon number 3, this is carbon number 4. Again, the double bond is on the second position. So if you number it from the left side and right side, and the location of the double bond is same for both of them, then you have to look at the branch. Here, if I number it from the right side, the branch would be on the second position. If I number it from the left side, the branch would be on the third position. So the blue system is not correct. The right numbering, the red one is correct. Okay, so the priority is with the functional group, with the double bond or triple bond. If from the both sides, the double bond and triple bond receive the same number, then you have to look at the branch. You have to number it from the side which branches receive a smaller number. Okay, so let's name this one. I have a methyl in the second position. So this one is 2-methyl. And the alkene with the 4 carbon is butene. But the double bond is in the second position. So I have to mention 2-butene. This one is 2-methyl, 2-butene. The third one, the longest chain would be this one. The longest chain which contains the double bond. If I number the parent from the left side, this would be carbon number 1, carbon number 2, carbon number 3, 4, 5, 6. So the double bond is on carbon number 3. If I number it from the right side, this would be carbon number 1, this would be carbon number 2, this would be carbon number 3. Again, the double bond would be on carbon number 3, but I have to number it from the left side because the branch would be in the second position if I number it from the left side. But if I number it from the right side, the branch would be in the 5th position. So again here, for the double bond, there is no difference from which side I number it. From the either side, it receives number 4. But the branch, if I number it from the left side, it receives number 2. If I number it from the right side, it receives number 5. So I choose the one which the branch received a smaller number. So the red one is correct. So I mentioned the branch first. It's methyl on the second position. So I have 2-methyl. Then I have alkene with the 6 carbon. And the double bond is on the third position. So I have 3-hexene. Hexene represents the alkene. This 3 is the position of this double bond. Let's go to the next one. Here again, you can see that you have the double bond in the molecule. So this is the alkene, but you have 2 double bonds. So this is actually diene. You have to find the longest chain which contains both of those double bonds. So the longest chain which contains both of the double bonds is this one. This is the longest chain which contains both of the double bonds. Now let's number the parent. If I number it from the top, this would be carbon number 1, this is carbon number 2, this is carbon number 3, this is 4, this is 5, 6, and 7. The position of the double bond, the first one is on the second position, and the next one is on the 5th position. Now, if I number this from the right side, This is carbon number 1, carbon number 2, number 3, number 4, number 5, number 6, number 7. The first double bond is on carbon number 2, and the next double bond is on carbon number 5. So again here, there is no difference for the double bonds from which side you number the parent. So let's go to check the branches. I have 2 branches here. Both of them are methyl. If I number the parent from the top, the first branch is on the 3rd position here, and the second branch is on the 6th position. So it becomes 3 and 6. If I number it from the right side, the first branch here would be on the 2nd position, and the second branch would be on the 5th position. So it becomes 2 and 5. So because for the double bond, there is no difference, I will check the branch, and I have to choose this one because the 2 is smaller than 3. So I have to number this molecule from the right side, because if I number it from the right side, the branch receive a smaller number. So this one is my parent, and this would be carbon number 1, this is carbon number 2, this is carbon number 3, 4, 5, 6, 7. I have 2 methyl brands in the 2nd and 5th position, and I have to mention the branches first. How I have to mention them? First, the position of them. They are in the 2nd and 5th position. Okay. Then because both of them are methyl, I just write dimethyl. So 2,5 dimethyl. Then I have to name the parent. The parent has 2 double bonds. The position of the double bonds are on the 2nd and 5th carbon. So it becomes 2, 5, and I have 7 carbons, so it becomes hepta. You have 2 double bonds, so it becomes diene. So it is 2, 5 heptadiene. Any question about this one? Okay, so if you don't have question, let's go to name the alkyne. The definition of the alkyne is given here. It says the alkynes, hydrocarbons with triple covalent bonds are alkynes. We talk about the straight chain of the alkynes. Here we want to talk about the alkynes which contains the branches. So look at the molecule which is written at the left side. It's just a straight chain alkyne without any branch. So you just need to number it to mention the location of the triple bond. You have to number it from the right side because the triple bond would be on the 1st position. You have 5 carbon, the triple bond is in the 1st position, so it's 1 pentane. The molecule which is at the right side, it has branch, so you must find the parent chain which contains the triple bond. This is the parent chain. You have to number the parents from the left side because the triple bond would receive a smaller number. It's carbon number 1, carbon number 2, carbon number 3, carbon number 4. But look what happens if you number it from the right side. This would be carbon number 1. This would be carbon number 2. This is carbon number 3. This is carbon number 4. If you number it from the right side, the triple bond is on the 3rd position. If you number it from the left side, the triple bond is in the 1st position. So you choose the blue one from the left side. But look at the branch here. In the branch, if you number it from the right side, the branch would be on the 2nd position. If you number it from the left side, the branch is in the 3rd position. So although the branch receives a smaller number when you number it from the left side, but you should not look at the branch. You have to look at the triple bond. The priority is with the triple bond. If the triple bond would be in the same position from the left and right, Then you have to look at the branch. So in this molecule, the methyl is on the third position. So you have 3 methyl and you have 4 carbons. So it's butane, and the triple bond is on the first position. So you have to mention the position of that one as well. So it's 3 methyl, 1 butane. So let's do some examples for the naming of the alkynes and alkene. Okay, this one we have done earlier. So let's go to part B. The part B, you have the double bond. So this is the alkene. You have 2 double bonds without any branch. So this is the longest chain, and it's your parent without having any branch. You have to number the parent from the side which the double bond receive a smaller number. Here there is no difference. If you number it from the left side, this is carbon number 1, 2, 3, and 4. So the double bond would be on the first and the third position. If you number it from the right side, this is carbon number 1, carbon number 2, carbon number 3, and carbon number 4. Again, the double bond is in the first position and the third position. So from both sides, same, no matter from which side you number it, the name of this compound would be the 4 carbon. So it's but with 2 double bonds. So it's butadiene. The position of the double bonds are 1 and 3. So if you notice, when you have 2 double bonds or 2 triple bonds, you will have the A here. Okay, but if you don't have, if you have only 1 double bond, it would be butene without A. But if you have 2 of them, when you want to use diene, you must have A before D. The next one, you have the triple bond there. So it means it is alkyne. Again, this one is a straight chain. So you don't have any branch. You have to only number it from the side which the triple bond receive a smaller number. The triple bond is located at the left side of the molecule. So if you number it from the left side, the triple bond receive a smaller number. You have 5 carbon. So this one is pentane. The location of the triple bond is on the second carbon. So this one is 2-pentane. Now let's go to the chapter review and do some practice on the name of the alkene and alkyne. We have done for the alkane, we have named the alkanes. Question number 15, we have done 16, we have done, and we have done it up to question number 18. No, let's go to question number 19 and name this one. Okay, so the first one, part A, you have the double bond without any branch. So this one is alkene. You have to number it from the left side because the double bond is on the left side of the molecule. And if you number it from the left side, the double bond receives a smaller number. You have 5 carbon, so it is pentene. And the position of the double bond is on the first carbon, so it's 1 pentene. Okay, for the next molecule, you have to find the longest chain which contain the double bond. The longest chain which contain the double bond is this one. So you have 1, 2, 1, 2, 3, 4 carbons. Also, you can choose this one to be your longest chain. Both of them are same. This would be carbon number 1, this would be carbon number 2, this would be carbon number 3, and carbon number 4. They are same because look at this carbon. To this carbon, one CH3 is connected here, another CH3 is connected here. So no matter which one you choose to be part of the parent and which one you choose to be as a branch, it's same. So this is the longest chain. How many branches do you have here? What are your branches?
Only one methyl.
Only one methyl, exactly. Okay, so I have only one methyl branch here. From which side I have to number it?
From the left.
From the left.
Yeah.
Yeah, for the double bond, there is no difference. Yeah, it's position number 1, this is 2, this is 3, this is 4. So if you number it from the right side, this would be number 1, this number 2, this number 3, this one is number 4. So from both sides, the double bond is on the second position. But if you number it from the left side, the branch receives a smaller number, number 2. So I have to number it from the left side. So I have one methyl group on the second position. So it's 2 methyl. Then I have the double bond on the second position, 2 with 4 carbons. So it's butene. So 2 methyl, 2 butene. The next one, the longest chain would be this. The longest chain which contains the double bond. It has 1, 2, 3, 4, 5. It has 5 carbons. Again, look at this molecule. You can choose this one to be longest chain. Actually, this one is longer than previous one. It has 1, 2, 3, 4, 5, but it doesn't contain the double bond. So you are not allowed to choose that one as a parent, although it's longer than the previous one. So the longest chain would be this one. Also, you can consider this one to be longest chain. In both of them, there are 5 carbons in the parent. Again, look at this carbon. What is connected to that? At the right side, you have CH2, CH3. At the bottom, you have CH2, CH3. So no matter which one you choose to be your parent, both of them are exactly same. But it's better to choose the one which is written straight as a parent. So this is the parent. I will have 2 branches then. One of them is methyl, the other one is ethyl. I have to number the parent. The double bond is at the left side of the molecule. So if I number it from the left side of the molecule, the double bond receives a smaller number. No, I mentioned the name of the branches. One of them is methyl, the other one is ethyl. The ethyl must be mentioned first because E comes before M. So on the third position, I write it here. On the third position, you have ethyl. Then again, on the third position, you have methyl. And you have 5 carbons, which the position of the double bond is on the first carbon. So you have 1 pentane. Okay. Part D, you have 2 double bonds here. So you have to choose the longest chain which contains both of them. This is the longest chain which contains the both of the double bonds. No matter from which side you number it, the double bond receives number 1, 2, 3, 4, 5, 6. They receives number 1 and 5. If you number it from the right side also, one of them on the first position, 2, 3, 4, and the next one is on the 5th position. So for the double bonds, there is no difference from which side you number it. But if you number the parent from the left side, the branch receives a smaller number. It receives number 2. So you have to number it from the left side. Okay, so let's name it. First, you have to mention the position of the branch. You have methyl on the second position. So you have 2 methyl. And then you have to name the parent. It has 2 double bonds on the first and 5th position. You have 6 carbons, so this one is hexa diene. Hexa because you have 6 carbon, diene because you have 2 double bond, and 1 and 5, which is in front of that, shows the position of these double bonds. So this was the naming of the alkene. Let's go to question number 20. It's the naming of the alkyne. So you can see the system for the naming of the alkene and alkynes are exactly the same. The only difference is at the end of the molecule. For the alkene, you have ENE. For the alkyne, you will have YNE. The first one, you have 3 carbon without any branches. So this is your parent. It has 3 carbons. So it's propane. Propane, ANE converts to YNE. Do I need to mention the location of the triple bond here?
No, because if you number it from the other side, again, it will be 1. So
Yes, it's not necessary to mention the location of the triple bond, because if the triple bond was here, so if your molecule was like this, CH3, single bond C, triple bond CH, if your molecule was this one, again you have the propene, but when you want to number it, you have to number it from the right side. In this case, it becomes 1, 2, 3. So the triple bond is on the first position. So this one would be 1 propene. For this molecule, you have to number it from the left side. This is carbon number 1, this is carbon number 2, this is carbon number 3. Again, the triple bond is on the first position. So both of these 2 molecules are actually same. They are 1 propene. So for the propene, the location of the triple bond is not important. So they are exactly the same molecule, just you have flipped the molecule, you have rotated the molecule. So in this case, it's not necessary to mention the location of the triple bond. Although if you say it's 1 propene, your answer is not wrong. Let's go to the next example, part B. In part B, you have triple bond, so you have to choose the longest chain which contains the triple bond. This is the longest chain which contains the triple bond. You have to number the parent. If you number it from the left side, the triple bond receives a smaller number because the triple bond is located at the left side of the parent. This is carbon number 1, this is carbon number 2, 3, 4, and 5. And this is your branch. So the position of the branch is on the 4th carbon. So it is 4 methyl. And you have triple bond on the 2nd position. So I write 2, 5 carbon. So it's pentane. So it's 4 methyl 2 pentane. Let's go to the next example, part C. Again, you have 1 triple bond in the molecule, so you have to choose the longest chain. This is the longest chain that I have here. I have 2 branches. Now I have to number the parent. Here, no matter from which side you number it, the triple bond is exactly at the middle of the parent chain. So from both sides, it receives number 3. This is carbon number 1, 2, 3, 4, 5, 6. If you number it from the right side, this is carbon number 1, this is carbon number 2, 3, 4, 5, 6. So you can see from both sides, the triple bond is on the 3rd position. So if for the functional group there is no difference, you have to look at the branches. If you number it from the right side, one of the methyl is in the 2nd position, the other one is in the 5th position. So it becomes 2 and 5. If you number it from the left side, the first methyl is in the 2nd position, the 2nd methyl is in the 5th position. So it's 2, 5. So again, for the branches also, there is no difference from which side you number it. So you can use any of them, no difference between them. So I choose the blue one. So the location of the branches, the first methyl is in the 2nd position, the 2nd methyl is on the 5th position. So I have 2, 5 dimethyl because I have 2 methyls here. Then the position of the triple bond is on the 3rd position and I have 6 carbons. So it is Hexane. Y and E at the end because it is alkyne. And the last example that we want to do here contains two triple bonds without any branch. So you have to number it from the side which these branches receive the smaller number. But again, in this molecule, there is no difference from which side you number it. So look, if I number it from the left side, this is carbon number 1, 2, 3, 4, 5, 6, 7. The branches are on the first and sixth position. If I number it from the right side, this is carbon number 1, 2, 3, 4, 5, 6, and 7. So again, they are on the first and sixth position. So no matter from which side you number it. So what would be the name of this one? Who can tell me what is the name of this alkyne?
It will be 1,6 heptadiene.
Exactly. 1, 6. You have 5 carbon, so it's hepta. You have 2 triple bond, so it's di. So this molecule is 1,6 heptadiene.